All right, hello. Welcome to a new video. Today we're going to do 249, 2495. This is the problem called number of subarrays having even product. And just before going through this, I just want to say that I already saw the solution to this problem, but I feel like this was a problem that was like kind of cool. So I watched a video of this person I watched named Larry do it, and the way he explained it was very concise and very interesting, and it really opened my eye to like I don't know, it was kind of cool just like watching him or hearing him just like talk about the problem and really explain it and made it really easy, right? So I kind of want to reciprocate that. I'm not really going to copy word by word, but I'm going to copy like the same idea and how how I would explain it, right? Because if this was an interview, how would I do that, right? So I'm kind of gonna do that in my own solution process that I'm gonna go through right now. Um, so yeah, so also this problem's kind of easy, but I don't have like 40 minutes, because I'm at work. I'm supposed to have a meeting in like 40 minutes. So um, I'm trying to get that time in with LeetCode, get some practice in because I have a lot of stuff to do today. Other than work, I have to drive for a long time. Right. So and I don't want to lose my streak because I like my streak. It looks really good. I like the green squares. Anyways, so let's go solve this problem. Right. So, in my solution process, I like to just explore the problem, like just read over it, get the input and output, and then I'll ask some questions if I have any, and then I'll go through some examples to showcase that I do understand the problem. And once I showcase that, I like to go over some approaches we can do to solve this problem. And once once there's like an optimal solution, I'm gonna head and plan it with some pseudocode. And once I plan it, I'm gonna implement and then review the time complexities and just go through the code once before running it, right? All right, so let's do that. So let me just read over the problem. So given a zero index integer array, so the zero index doesn't really matter. So just given a integer array nums, return the number of subarrays of nums having an even product. Okay, so input is going to be what's going to be an int of nums. Are they negative? Are they could they be negative? That's a question that I would ask. Okay, they can't be negative. An int of positive nums. Oh, an int array. And then our output's going to be um num. Oh, I could just do like this. Cool. Array of pos nums, and then the output's gonna be num of sub arrays and input or pos. They're even. There you go. My morning brain is kicking in. Just woke up like an hour ago. Coffee's good. All right. Anyways, so I think the question I said like if they're positive, I think that's only um those are the only things that make me want to ask a question. So yeah, that's sorted out. I would ask the interviewer, but I just scroll down on LeetCode just to make sure. So, even though I don't think like that would be an issue, because even a negative number can be positive, but I just asked it because I don't know, it's just always good to ask questions, and even though they might be stupid, I think it showcases you that you can communicate your whatever you're thinking. I guess I think it's okay. It's whatever. Stupid questions are always good questions too. So now that I got my input and output and right over the problem, I know what I'm gonna input and output. So let's go ahead and go through some examples. Okay, so example one, right? Let's say we have an array of like 1, 2, 3, 4, 5, 6. If we go through this, how many positive subarrays are there? Well, we can do. Actually, let me just make it simple because my brain's not working right now. Right, let's do this. So, we got 1. Okay. Then we got 1, 2. Okay. Then we got 2. So currently we have two subarrays that are even, uh, 1, 2, and 2. Then we have um, 3 is not positive. 3 is not even. I say negative and positive. Then we have 3, 2, 1. It should be even. That's 3. Um, okay, so let's do example 2. Make it harder, I guess. Let's say we have like 3, 5, 8, 7, 8. Okay. All right. So here times 5, 15. Times 7. That's whatever. Right. So these are whatever these arrays are or could be. They are not even. But if we have this 8, an even number times odd number is always even. So we'll have the output of 1, right? Because there's only one even subarray. But let's say, okay, so let's say if it was example 4. Okay. So we have 2, 4, 6, 8. So 2 could be its own subarray, so that's 1. 4 could be its own subarray, and it could be 2, 4, so that's 3 so far. And 6 could be its own subarray, along with the subarray. Wait. Okay, so 4, then 5, and 6. Okay. Then 8 could be its own subarray. So that's 7, and 8, 6, so it's 8. 8, 6, 4, that's 9. 8, 6, 4, 2, so that's 10. All right, so there is a pattern here. Of course, a subarray can be length of 1, right? And then a subarray is a contiguous array of numbers that are next to each other, basically. So that's kind of the pattern, right? So yeah. Let me think. My brain's so fogged up right now. I said example 4 instead of 3. That's how you know. Alright, so we went through some examples. Like we kind of understand how this problem works. Let's go and see what kind of approaches we can do. So approach. So for me, if I did this by myself, right? Just going into it, I'd probably do like 2 pointers. 2 pointers, um 2 pointers, but that'll be O of n squared, I'm pretty sure. Because I would say, okay, start at 2, then go to 4, 2, 4, 6, 2, 4, 8, and then 4, 4, 6, 8, right? Then 6, 6, 8, then 8, right? Just stuff like that. Okay. So, all right. And so, that's the kind of approach I would do if I did this solo or like blind. But one thing that Larry did, that he did single pointer and then looked left, and then he did a communicative property. That's kind of like a math thing. But basically, since we're doing like a subarray, so for example, let's just say example 4. This is the real example 4. Let's say we have all odd numbers, so 2, 1, 3, 5, and then 4. Okay, so from this, we can say 1 times 3, that's 3, and so on. 3 times 5, that's 15. So odd numbers will always have odd numbers, but even times even is, okay, so so even times even is equal to even. It's true. It's 2 times 2, that's 4. 6 times 4, that's 12. And then odd and even is equal to even. And odd, so 3 times 3, that's like 9, so that's always odd. And yeah. So that's kind of it. whenever we have an odd number and even number together, when they multiply, it's always positive. So we can say, right, because like if we have a 4 right here, then that means that this whole subarray could be even. And we could also say that like a subarray is contiguous, right? So we can say 4, 5, 4, 3, and 4, 1. So that's 3, right? Wait, 4, 5, 1, 4, 3, 5, it's 2, 4. Okay, yeah. 3 plus plus the number itself, like in its whole other array. So there's a pattern there, right? And we just gotta figure that out. So whenever there's an even number, um, whatever before it, like there's three. So there's three elements before the 4, right? So that means there could be three. So there could be 3 subarrays that are even, right? I'm pretty sure. I'm pretty sure. Now the whole thing to do is we actually gotta code this out, right? And also if there's like a 6 here, right? So anything before the 6 could be a subarray, positive subarray, right? We have 6, 4, 6, 5, right? There's a pattern here, but I just don't know how to do it. I already forgot the pattern, but I know it's there. I just gotta realize how to code it, right? Let's go through some planning, how to code this. So let me think. Let me think. So I was gonna go through a for loop. This is gonna be solved in n time because we're just gonna count like where we are, and then what index is the one with a positive, right? So let me think. Hmm. Okay, I guess we can start off small. So let's see. Hmm. Okay, so we're gonna do a for loop. So iterate through through list. So for I in list. Okay. So we're gonna say if I is even, then we're gonna make that we're gonna say that index. Because if we basically go through this, right? So we're at 4 right now, right? This is index 3, and then this is 0, 1, 2, so that's basically 3. So basically anything before this index, we're going to add it, right? So let's say that we are at index 3. We just say, okay, so the amount of subarrays before this, because we just stumbled upon an even number, right? So we know anything before this 4, we can make an even subarray with. So we're gonna add 0, 1, 2, and 3. So we're gonna add 3 plus 1. So then we're gonna say then we're gonna say yeah, we're gonna say um even subs equal to I, right? And then we're gonna do plus 1 because we have to also include the 4. And then the same could be said here if we found an even number, right? We can make it an even. We can make a subarray with 1 all the way to 6, 3 all the way to 6, and then 5 all the way to 6, and 4, 6, and then 6, right? So and then from there we can just return. Oops, that's so weird. Why does it do that? And then we can just return even subs. I'm pretty sure that would work. Let me just code this. So I think this plan works. It makes sense. It makes sense. So 0, 1, 2, and 3. Yeah. Plus 1, 2, and also include the because this is 0 index, right? So I gotta include the 1. So it's actually 4. Alright, so let's go plan this out. I mean implement this out. So I'm gonna make a main function, pass it, and then I'm gonna run min in this whole file itself. Then I'm going to create a helper function that solves this problem. So get get subs, I guess. Get even subs. Okay. I'm gonna take it in a list of nums, so just say nums. I'm gonna pass it for now, so it looks good. And then in the main function, I want to get user input, so I'm gonna say that nums is gonna be equal to a list of integers. So we can get input dot split, so we get it into a list, and then for those, for elements in input dot split, we're going to turn those into integers, and then put this all in this list, and then I'm gonna call get even subs with the argument of nums. We're gonna pass on nums to that. Then we know that from our plan that even subs is going to return an integer that gets the even amount of subarrays. So I'm gonna print out its return value, and then from there, we can go ahead and go on with our plan, right? So basically, we're just going to iterate through the list, but first I need to initialize a variable to hold even amount of subs. So even subs can equal to 0. And then so for I, I'm going to iterate through it, right? So for I and range, starting from 0 all the way up to the length of nums, we're just going to say like, okay, so if nums at I is even, which we say modulo divided by 2, we can say that even subs is going to get incremented by I plus 1. So let's go through that again with like an example. And also have to return even subs, right? Once we go through this for loop. So I think this example is good. Oh wait. Ooh, I didn't get this case out. Oh, I didn't get this case out. Okay, so I know this is 3, right? But 1, 2, and 3 could have a subarray, but the way that I have it right now is that yeah, the way that I have it is that oops. Okay, so you're basically looking all the way to the left, basically. But for this example, if we're at nums at I where it's 3, right? It doesn't get the case where it detects 3 and 2. It only detects like the left of this. So I think I can say like how can I say this? Okay, so what can I say? Then we have, let's say we have 5 and 7, right? Why do I do that? Okay, so it can be 3, 2, it can be 5, 3, 2. So I guess how are we gonna count that? So 4, I guess. I'm trying to figure out this out. So okay, so we have 2 here. Okay, so I can say like, okay, so if it's not negative, I mean if it's not positive, so else, then we can say for every positive number there is, yeah, for every I say positive. For every even number there is in the list, when we passed it already, and the number that we're on is not is odd, we can say so this would be 4, 5. Okay, so that's 1. And then this could be 4, 5, 3. Ooh. Okay. Ooh, how do I do that? Okay, I'm trying to think. Okay, it's kind of like the same property because if we go look to the left, we do have a we do have a there is a positive number, right? I mean, even number. So you can say 5, 4, right? And then 3. And then, okay. 5, 4, 3. So that's one. We could do that. So that's 1, 2. That's that. 3, that's that. 4, that's that. So I guess then I guess we could say like, so if even subs, so else, and then we can say like if even subs is more than equal to 0, then we could say everything past that. So let's say we have like let's say we don't have this 4. So we can say that um that it can be 3, 2, 3, 2, 1, right? It's basically at this index plus no, yeah, it's basically everything at this index. So 0, 1. So but that's basically 2. So we can have like 2 subarrays from here, right? Um and so we got 2 subarrays, so we can say even subs plus equal to I. So that makes sense. Yeah, I think that works. Then we just return even subs. So let's go through this with this problem. Okay. Okay, so hold up, let me actually go through it with like an actual example. So 9, 6, 7, it should output 6, right? Okay. So go with this example with my algorithm. So it's like example 5. Okay, so have it like here, it should be 6, right? Okay, so right, so 0, we're at index 0, so that's 9. And then we're at index 1. So if it's is even, then do then make this 2. That's 2, right? Okay. And then yeah, so 1 plus 1, that's 2. And then we're at 7. So else, if even subs is more than equal to 0, okay? So it is. Then we do even subs plus I, so 2. Because this and this. Okay, so 4. And we can do, then we're at 13, right? Then we have, oh wait, did I do it wrong? Yeah, I did it wrong. Oops. Did I do it wrong? Because it should be 6, right? Ooh. No, I think I'm right. Wait, did I do double duplicate? Oh yes, I think I did. Um, yes, because I did. Oh, okay. So if we passed it, right? Because yeah, so if we passed it, okay, so yeah, so if we already passed the even number, Because when we get to an even number, we already do 6 and then 9, right? And then once we hit an odd number, we already do when we hit an odd number, when we say plus equal to I, then we're basically saying all of these, right? But what we should be really doing is we don't want to repeat this. We don't want to repeat this all over again. I guess we could just do +1, right? Isn't that how it works? No, I'm right. Wait. Okay, plus I. Am I tripping? Oh wait, no, wait. I think I'm tripping. Cause yeah, so this. But I say I need to redo this again. Okay. My brain's not good right now. Okay, so we skipped 9, so we're at 6. Um okay, so we're at 6 now. And then we say everything to the left of it could be a subarray, so 6 itself. So so the 9 6 and then 6 itself. That's 2. We're at index 1. So it's 1 plus 1, okay? And then we're at 7 right now, right? So which is index 2. So then we're like, okay, so if it's not even, then everything, so we're saying that this could be 1 and this could be 1, so that's 4, right? And then from here it has to be 6. But here I say we're gonna add plus I, right? So what could that mean? So this is 13. I mean, so this is at index 3. We will be plusing 3, right? That would make any sense, right? So, but the real case is this, and this. Let's say plus 1. But I say plus 3. Huh. Let me think about it. So this should be 6, but I'll put 7. So if it's not even, so if it's odd and it's behind, what I'm saying is this. Like this is valid, but it's not. It shouldn't be. Hmm. This is interesting. I'm trying to think of like how to make this work. Um, because this is the even number, right? 6 is the even number, and I want to get this as a subarray. Um, so it'll be 1 subarray. And this could also be a subarray. My guess is that for every even number, we can have So for every even number, we can have like a yeah. For every even number, we can have a subarray if we land on an odd number. Let me see. So here this would be 2, right? So 2. If you have let's say 2 here. Okay. So we can have this 2. That's 1. This is 1. This is 2. This is 3. This is 4. There's 2. It's 4. Okay. Then let's just say there's an 8 here. Okay, so 1, 2, 1, 2, 3, 4, 5. Wait, how did I get? How did I get? Wait, hold up. How did I get that? Okay, so okay. So 1, 2, 3, 4. That's 4. Okay. 1, 2. Okay. So it goes up by 2, I guess. Say 2, 8, 13. Okay. So 1, 2, 3, 4, 5. Wait, I'm tripping, right? 1, 2, 3, 4, 5. Wait, okay, so how does this work? How does that work? Wait, this is kind of... Okay, my meeting's in like 6 minutes. I might pause this and come back. I thought I had this problem solved. Okay, so I think I figured it out. What I was trying to do. So I was trying to get like, how do we... So I got like 3 minus 2. 3 minus 1 is equal to 2. So basically, starting from the range of 1 through starting from the range of 1 all the way up to range of 3. I'm starting from 1 to the range of 3. We get this, so it's 2. Right, so I'm trying to get like, this is a subarray, right? This is the length of the subarray. But I know that we could have a subarray like this. So we can say, because anything past this is going to be, anything to the left of this 6 is going to be a part of the subarray, or can be a part of the subarray too. So I can say, if we get this length, right? Then we can say, okay, then anything to the left of it. So we can say like the length. So 4 is 0, 1, 2, 3. So we can say 3 minus 2 is equal to 1. So there's going to be an extra subarray right there too. So I can say, I can say, so if it's odd, then we're going to do, we're going to do even subs is equal to, wait, I actually didn't think about that part. Okay, so even subs equal to the start plus 1 and plus length minus plus length of nums minus ooh, not sure this will work, right? So 1 plus like the nums minus even index. Oh yeah, I had added an even index for this part. Even index plus I. That makes sense, right? So again, okay, let me just go through that again. Okay, so we have so we're at 9. It doesn't have any even subs yet, so we skip. We're at 6. This is the even number. And so we do I plus 1. So I is currently 1 plus 1, that's 2. So there's 2 subarrays here. Because we can do this 9, 6, and 6. So it's 2. And we're at 7, right? So we can do, okay, so if even subs is more than equal to 0, which is true, that's 2 right now. So even subs is equal to um, length of nums. So length of nums is 3 minus index, which is currently 0, 1, 2. Wait, did I do it wrong? Wait, what? I want to get the range of this. So it's 6, 7. So 2 minus. So 2. Okay, so it's currently um it's currently 1. That's currently 2 minus 1 is equal to 1, right? And I'm like, okay, so this whole thing is a length of 2. Oh, so I can say 2. It's 1. Wait. Two minus. Wait, wait, I'm so confused. Oh, my brain's not working. I'm trying to get this 9. So this is length of 2. Length of 2. So I is basically 0, 1, 2. So 2. I want to get this, which is I could say maybe length of, so I plus 1. I plus 1 minus, I plus 1 minus even index. That makes sense because even index is, even index is currently 1. I plus 1, that's 0, 1, 2, so it's 2. Plus 3. No, plus 1 is 3. No, what makes it has to be I minus even index. So it's plus 1. And then everything behind it. So instead of length, I can just say 1 plus I minus EI, right? So we're currently at, okay, that makes sense, I think. So we're getting the 1 that comes from this, and then the I minus EI. So I is currently 2, 0, 1, 2. EI is 1, so 2 minus 1, that's 1. Basically, there will be one more, right? Because that's the range of what's before it. I'm pretty sure. Yeah, that makes sense. And then okay, so if we do that, so we do 1 plus I, which is 2, minus EI, which is 1, so it's 4. I mean 1 plus 1 is 4. Oh. Yeah. Okay, so that makes sense. This makes sense. It's just taking a while. I think my brain's working right now. Um, and then here, let's test out with this one. So we're currently at 4. So we're at 13 now. Okay. So if it's not even, I will go here. And so okay, so if even sub is equal to plus 1. Okay. And then whatever's behind it. So EI, so I minus EI. So that is 3 minus 1. That's 2. I don't think that's how it is. Um, I think I figured it out. My mind's not working today. I only had like, I don't want to make an excuse for myself, but yeah, I think I'm just stupid. But that's fine. I'm not that stupid. I'm just like stupid right now. Okay, so I can say even subs equal plus 1. So basically this 13, 6, 7, the subarray, and then everything behind it, right? So everything behind it's gonna be the even index, because right. So 0, 1, right. So it makes sense that anything behind this one is a part of it. I was trying to do like defining the, I don't know, but yeah, this makes sense. I was like, okay, here's my brain. So my brain was like, okay, so we're at index 1. So what minus 1 is equal to 0? Think about that for like 5 minutes. I was like, how do I do that? Do I make a for loop? So like decrement 1 each time loop, and then we get the amount of times it looped. But yeah, it's 1. 1 minus 1 equal to 0. That's the only answer. So that's why my brain wasn't working. Yeah, so this makes sense. Let's try it with this solution again. This problem. Okay, so we're at 9. Even sub is more than equal to 0, so we don't go through this if statement. Is not more than equal to 0. And then here we're at 6, so 6 is at index 1, right? So if I is even, which is true, even sub is equal to I plus 1, so 1 plus. So I is equal to 1, so plus 1 to include itself. Everything before it. I'm not sure how I didn't get this because, and I applied it to here because it's like the same idea. Like everything, but everything before this has to be included, right? So plus 1, and even index gets updated, right? And then here, so that's 2. And then we're like, okay, so if the index rat has a odd number, we say, okay, we gotta include this range, right? 7 to the even number as a subarray, and then we gotta include every number before it, so we can do like 9, 6, 7, right? So EI, so anything before EI, or basically at EI, okay, that's the amount, right? That's the range is included. So as a subarray, so EI is at 1, so 1, right? So that's 4 because we did the plus 1 as well too. And here we got the 13. Okay, so it's not odd. I mean, it is odd. So let's say plus 1 to include the 6, and then anything before it, which is the EI. EI is 1, so it's now 6. So 1 plus 1, 6. All right, so now that should work. So awesome. Then also have even index is equal to 0, I guess. So then else if even subs won't equal to 0. Then we're going to say that oops, I also forgot to get the even index once we find the even number. And then the even sub is more than equal to 0. I'm going to basically say even subs is going to equal to 1 plus even index. That should work. We already went through an example, so I think it's fine if we just like copy paste it in LeetCode, I think. Let me see. There you go. Hopefully this works. Please run. Wrong answer? Are you serious? I was at 7. Wait, I thought it was 6. Right? Did I do my math wrong? Wait, what's the answer here? Oh, oops. Uh, oh, okay. So if even subs is more than, oopsie. That's a fumble. There you go. Wow, and it runs. Awesome. Wait, that's so cool. All right, that's awesome. Oh my god, it took me like 45 minutes to solve this medium problem. It should have been way easier if my brain was working today. But I just woke up. Yeah, I'm kind of happy that I finished this, solving it by myself and debugging it by myself. I had a meeting in between, so it gave me time to think extra. So yeah, but still, like I think like 46 minutes raw is pretty good. Although it's not raw, like the like explaining it was kind of helpful. Yeah. So to evaluate, this was let's go and review it. So evaluate I mean. So let's see. So for time, basically iterating through this. Um for every element we're iterating through it. It has O of n, right? O of n is the list size. And then for space we're using constant variables such as like just like we're not even using any data structures to solve this. So it's O of 1 space. So yeah, pretty cool.